So if we were to look at um, the distribution of solar energy, you would see that the Earth is a sphere. Don't forget that. And because of that, the beams that strike the Earth spread out over an area. So you can look there in figure A and see how even though it's striking in that area and it's hitting in that area, it spreads out over a further area. And then if we look at the seasons, you can see as we rotate around the sun and we also rotate on our axis, how it's going to cause one part of the earth to be facing the sun, that'll be our summers, and the part of the earth that's away from the sun will be our winters. Now looking at global wind circulation, this brings us to objective 2. Describe how global air circulation patterns and topography help produce various patterns of temperature and rainfall that determine the Earth's climate. Well, when you look at this, remember, air ascends and descends. And the reason this happens is because the Earth rotates on its axis. And when it's ascending air, it's moist and it's cooler and it's going to lose the moisture. But when it's descending, it's going to be warmer and drier and retain the moisture. So you can see how the patterns of the wind are in that picture. Now if we look at rain shadow, we're going to talk about topography here. This is the physical features of the land. If you look at a coastal mountain range, for instance, like you have here, the windward side of the mountain, that's the coastal side, you see the winds are rising. It's got a lot of moisture, so it's going to receive a lot of rainfall. But on the leeward side, the interior side, those winds are not there as much, and so water's going to evaporate. It's not going to rain much at all. It's going to pretty much be clear weather most of the time. That's because it creates what's called a rain shadow.